Inline monitoring of the drying process of battery slurry. This is our today's topic, and with this, welcome to our today's video where I introduce to you a sensor suited for this application. In general, there are 5 stages of drying, and our sensor can precisely identify the transition between stage 2 and stage 3. In stage 1 and 2, at the beginning of the drying could be very aggressive. However, in stage 3, you have to be quite careful. Otherwise, there's the risk of binder migration by capillary forces to the material surface. If this happens, then the active material, like graphite, NMC or LFP, wouldn't stick to the current collector anymore. The sensor works as follows. First, we apply a modulated laser load, and second, we have a look at the material's temperature answer via an infrared photodiode. And what we now evaluate is the phase shift between the laser excitement of the material and the material's response. And this phase shift scales with the thermal conductivity. For example, if a material has a high thermal conductivity, the material's response will be immediately, so the phase shift will be short. Let's now transfer this knowledge to the drying process of a battery slurry. During the drying process, the thermal conductivity changes, and so changes the phase shift that we measure with our sensor. And the point of the highest thermal conductivity is exactly at the interface between stage 2 and stage 3. And this is where my sensor shows you a minimum. By the way, at this point, you do not have any pores yet, but a high ratio of active material to solvent. The sensor can be used in combination with various drying technologies such as convective drying, infrared drying or laser drying. And by this use case today we start with laser drying, so stage 1 and 2. Then we identify the transition to stage 3 with our sensor, and then continue with convective drying. And for more details, please feel free to contact me.